Imagine a winter night, so cold the air feels heavy in your lungs. You walk outside, your breath instantly turning to frost, and within seconds your instinct kicks in. You pull your collar up, rush back inside, and turn up the thermostat. If the power goes out, you light a fire or huddle under synthetic blankets designed to trap every single watt of your body heat. Now, strip all of that away. Take away the insulated walls, the modern fabrics, and the blankets. Finally, take away fire itself. No matches, no sparks, no glowing embers. For the vast majority of our evolutionary history, this was the baseline reality. Our ancestors expanded out of the warm cradles of Africa and into the unforgiving landscapes of Europe and Asia during the Pleistocene, an era defined by massive ice sheets and brutal cyclical ice ages. Yet for hundreds of thousands of years before the widespread control of fire, these ancient hominids didn't just survive the freezing temperatures, they thrived. We often treat the discovery of fire as the definitive starting point of human survival in cold climates, assuming that before the flame we were helpless, shivering creatures at the mercy of the elements. But biology and archaeology tell a completely different story. Long before we learned to tame the spark, our ancestors possessed an incredible hidden toolkit of biological adaptations, behavioral strategies, and environmental engineering that kept them warm in a world of ice. To understand how they did it, we have to look inside our own bodies because we still carry the genetic ghosts of those who survived the Great Freeze. Let's start with the human engine. When you get cold today, your body does something automatic. You shiver. Shivering is a mechanical emergency response. Your muscles contract and relax rapidly, generating heat through pure friction. It works, but it is incredibly inefficient and drains your energy reserves at an unsustainable rate. But our ancestors had a far more elegant internal heating system that modern humans have almost completely lost. It's called brown adipose tissue, or simply brown fat. Most of the fat on a modern human body is white fat, which serves as energy storage. Brown fat is entirely different. It's packed with iron-rich mitochondria, and its sole purpose is to burn calories to generate pure, direct heat without shivering. This process is known as non-shivering thermogenesis. If you look at a newborn human infant today, you will find they have relatively high concentrations of brown fat around their neck and spine. This is because infants cannot shiver effectively. They rely on this ancient biological heater to keep from freezing. As we grow up in climate-controlled environments, our bodies realize they no longer need this expensive tissue, and it largely disappears. But for ancient humans, exposed to the elements from birth to death, brown fat was a lifelong asset. Their bodies were packed with it. When the ambient temperature dropped, their nervous system would signal the brown fat to activate, turning their own metabolism into a raging furnace. They weren't just insulating themselves against the cold, they were actively generating warmth from the inside out, maintaining a stable core temperature even while sleeping naked on frozen ground. But generating heat is only half the battle. You also have to keep it from escaping. The human body loses heat rapidly through its extremities, the hands, the feet, the ears, and the skin. To prevent this, our ancestors relied on an incredibly sophisticated vascular defense system. The moment the skin registers a drop in temperature, the blood vessels constrict. This process, called vasoconstriction, shunts warm blood away from the surface of the body and deep into the core, protecting vital organs like the heart, liver, and brain. However, if you keep the blood away from the hands and feet for too long, the tissue dies from frostbite. To counter this, ancient humans possessed a highly developed physiological reflex known as the hunting reaction. Every few minutes, the constricted blood vessels in their extremities would suddenly dilate, sending a temporary rush of warm blood to the fingers and toes to keep them alive, before constricting again to save the core. This constant, rhythmic pulsing of blood allowed them to maintain manual dexterity and protect their limbs in sub-zero environments without sacrificing their internal warmth. It was a flawless, automated dance of fluid dynamics happening beneath the skin, a biological technology perfected over millions of years of exposure. Yet biology can only take a solitary organism so far. When the biological limits were reached, behavior took over, and the most powerful behavioral weapon ancient humans had was each other. In the field of thermodynamics, there is a fundamental rule. A large object loses heat much slower than a small object because it has less surface area relative to its total mass. A single human standing alone in a freezing wind is a small object, radiating precious warmth out into a vast cold void.
But when a group comes together, the math changes entirely. Our ancestors practiced what anthropologists call social thermoregulation, or more simply, huddling. By packing tightly together into a single dense mass of bodies, they effectively altered their collective geometry. They drastically reduced the total surface area exposed to the freezing air while combining their individual metabolic heat outputs. In a tight huddle of 20 or 30 individuals, the microclimate at the center of the group can reach temperatures comfortable enough to rival a modern heated room, even in the middle of a glacial winter. The group became a singular thermal organism. They would rotate positions throughout the night, with those on the outer edges eventually moving into the warm core, ensuring that no single individual bore the brunt of the cold for too long. This wasn't just a casual way to sleep, it was a strict survival strategy that forged deep social bonds and rewrote the rules of mammalian survival. Where you choose to create that huddle mattered just as much as the huddle itself.
Ancient humans were masters of identifying and creating microclimates, localized spaces where the ambient conditions are significantly milder than the surrounding environment. The most obvious of these were caves. Deep underground, away from the surface winds, the temperature of a cave stabilizes, reflecting the average annual temperature of the region rather than the daily extremes. A cave could be a steady 40 degrees Fahrenheit inside while a blizzard rages at -10 outside. But caves are rare, and competition for them with large predators like cave bears and hyenas was fierce. When caves weren't available, our ancestors engineered their own shelters from the earth itself. They would dig deep depressions into the ground, creating subterranean sleeping pits. By getting below the surface of the earth, they escaped the convective cooling effects of the wind. They would line these pits with thick layers of dry vegetation, such as ferns, grasses, and pine needles, creating dense mats of natural insulation that trapped pockets of air beneath their bodies. But they also utilized a secret, hidden source of warmth that we rarely think about: decomposition. By piling large amounts of damp organic matter at the bottom of their sleeping nests, they triggered a natural process of microbial decay. As bacteria break down organic material, they generate significant amounts of heat as a byproduct. Ancient humans were essentially sleeping on slow-burning biological heating pads, using the metabolic energy of microscopic organisms to keep the frost at bay. To keep these internal and external systems functioning, our ancestors required an immense amount of fuel. You cannot stay warm in an ice age on a low-calorie diet. Before the advent of cooking, the human diet in cold regions was dominated by raw animal fats and proteins. When you consume a heavy meal, your body's metabolic rate spikes as it works to break down the nutrients. This phenomenon is known as the thermic effect of food. Protein and fat require significantly more energy to digest than carbohydrates, meaning that the act of eating them actually generates a substantial amount of internal body heat. To survive a freezing night, ancient hunters would consume massive quantities of raw megafauna meat, animal fat, and bone marrow right before settling down for the evening. This high-fat, high-protein intake acted like throwing heavy, slow-burning logs onto their internal metabolic fire. The intense digestive process would keep their core temperatures elevated for hours while they slept, turning their stomachs into a critical component of their thermoregulatory strategy. Finally, there was the use of external coverings. Long before the invention of needles, thread, or tailored clothing, ancient humans utilized the natural insulation of the world around them. They would drape themselves in the raw, unkempt hides of the animals they hunted, utilizing the thick fur to trap a layer of still air against their skin. They would layer moss, bark, and dried leaves between these hides to create primitive, highly effective thermal barriers. They were not passive victims of their environment. They were active participants, manipulating the physics of heat transfer with every tool at their disposal. We often look back at our pre-fire ancestors and see a fragile species waiting for a technological miracle to save them from the dark and the cold. We view fire as the tool that made us human. But the truth is, we were already human long before the first campfire was lit. The ability to endure, to adapt, to engineer survival out of nothing but flesh, bone, and collective willpower is our true evolutionary inheritance. Fire didn't create our survival skills. It merely gave a highly adapted, incredibly resilient species a new tool to play with. The next time you feel a chill on a winter evening and reach for a blanket or a thermostat, Remember that flowing through your veins is the blood of survivors who conquered the ice ages with nothing but the heat of their own bodies and the strength of the person standing next to them.